Okay, so what would be the equilibrium temperature of the Earth? So the question is, what temperature does the Earth have to be to radiate an average of 258 watts per square meter? Okay, because at an equilibrium temperature, the net radiation is equal to the net incoming radiation. If the incoming radiation is more on average than the outgoing, then your temperature is rising. And if the incoming radiation is less on average than the outgoing, then your temperature is falling. But let's assume it's neither falling nor rising. So it's at equilibrium. Okay, then that means in equals out. Okay, and we know that the outgoing radiation of power, in terms of power, right, is energy sigma area temperature of the Earth to the fourth, right? Now, if we turn that into an intensity, intensity is just power divided by area, right? So luckily, we don't need to involve, 4 pi r squared or anything here, right? This is the intensity. It's watts per square meter. So we're going to end up with this intensity is equal to emissivity times Stefan Boltzmann constant times the temperature of the Earth to the fourth. And it even gets better than this, right? We haven't been given an emissivity to use for the Earth, so we're going to pretend that it's a black body, right? Which is what IB seems to do, right? Whether that's correct or not, I just don't know. Okay, so now we're all set. We can just set this up, right? We've got 258 watts per square meter is equal to 1.00 times 5.67 times 10 to the minus 8th. And this is watts, meters to the minus 2, kelvins to the minus 4, times the temperature of the Earth to the fourth. Okay? Now notice that this all works out, right? This will be kelvins to the fourth. That'll cancel this out, and now you have on this side watts per square meter, watts per square meter. So the unit gods will be happy here. Okay, so this is ultimately going to be, the temperature is going to be left parenthesis 258 divided by 5.67 times 10 to the minus 8th. And then I'm going to raise that to the 0.25. 259.7. Temperature of the Earth. Now, I hope you realize that that's too cold, right? Your average Earth's temperature is something like 287 or something like that, right? So we need the greenhouse effect. We rely on the greenhouse effect. Otherwise, the Earth would be just frozen, okay? But, we want the greenhouse effect to a certain amount, not like an infinite amount of greenhouse effect, right? Too much is bad. Too little is bad. All right. Just got to be just right.